as mentioned, we're going to be talking about our 20 plus versions in production. We're going to sort of skip over the points where we tried Istio when it was pre 1.0, because no one had a fun time with that. And we never got it into production, really. Just quickly, for those who don't know who Skyscanner are, we're a meta search engine of flights, hotels, car hire, and now packages as well. We've got over 160 million monthly active users, over 1,200 travel providers that we aggregate. And that produces a lot of traffic, a lot of microservices, as previous talks have sort of covered. I'm a principal software engineer there within our production platform organization. I'm also co-chair of SIG autoscaling within Kubernetes.
Hello, I'm John. I'm a senior software engineer at Skyscanner. I've been at Skyscanner for about 2.5 years now, and I've focused mainly on Istio as my day-to-day work.
Sweet. So we'll quickly cover why Skyscanner decided to use a service mesh, because it's entirely possible to run cloud-native software without a service mesh, despite what some vendors might tell you. Our initial launch of Istio 1.4 as our service mesh in production, upgrading all the way from Istio 1.4 to 1.24, and we're now at 1.26. And also the future. So some of the benefits, a lot of the challenges that we've experienced along the way as well. So why use a service mesh? We had the classic we should use a service mesh. It's the hot cloud native technology. Everyone's saying, oh, Istio is amazing. It's backed by Google. But we sort of got a long way with our journey in containerization, cloud native technologies, without actually using a service mesh. So we sort of felt a need to actually justify it. So to sort of understand that, I'll cover the evolution of our architecture with containerized applications. So we started off in AWS with one ECS cluster because we weren't sure about this Kubernetes 1.2 thing. It wasn't backed by AWS, which was our cloud vendor of choice. So we were like, we'll see where it goes. We'll go with the technology backed by Google. It seems like it's got a load of impetus. And we achieved that by deploying a single ECS cluster. Each service got deployed in there. It had a load balancer and therefore a predictable DNS name in front of it. So that allowed services to talk to other services. But obviously that results in one big single point of failure. We eventually ended up basically recreating that architecture, but in Kubernetes, because that's an evolution and we've obviously improved things there. But in this case, we have at least stopped paying AWS for quite as many load balancers, because we can stick a single load balancer in front of it, and we can just do, using native Kubernetes technology, we can just do a single service name under that cluster. Obviously, that eventually starts hitting scale problems, particularly the versions of Kubernetes we're running. So we're like, okay, let's just split it into two Kubernetes cluster. That's an improvement. Oh wait, now everyone needs to know where their dependencies live. So now if I'm talking from service A to service B, I need to know that service B lives in cluster 2, not in cluster 1. I'm using that as part of the addressing. And also, actually, it's not improved our resilience, because if there's a cluster 2 outage, oh wait, cluster A, service A can no longer talk to its dependencies, we've not got any failover, etc. So we decided to steal from AWS's famously resilient cellular architecture that means that a single region going down will not impact the entire world, and create multiple Kubernetes clusters with an isolated account, and those would all be single AZ as our fault boundary. So now, if cluster A2 goes down, we can just route traffic away. So this is the architecture we came up with to enable that. So we were using NLBs. We have a component that we call the default gateway. John will cover that in a bit more detail, some of the benefits it brings us. And we decided, yeah, Istio's 1 point something now. We can definitely run this in prod, right? So we sort of chose Istio 1.4. Well, we started evaluating 1.3 and it was broken enough that we went, no, we'll wait for 1.4. However, we did start running into some compatibility problems. So Istio 1.4, we discovered did not play nice at all with our CNI choice. We needed to run our own custom patch to make it work. You can go and look up all of the detail and like the IP tables that made this a problem. We also had to start doing our own certificate management because that's fun. We decided very quickly we didn't want to pay AWS to do certificate management for us because it turns out they charge a lot of money for that. So we went, we can write a KMS issuer for Cert Manager for that, which we still use to this day. It works fairly well. And that's open source as well if anyone else wants to use it. We also, thanks to our friends from Monzo, decided to steal the ability to make services wait for Envoy to actually be ready before sending connections, because it turns out that's not a fun thing. But we also decided to implement some of our own technology to deal with some problems we were having. So we implemented using locality weightings, cluster draining. So we provided the ability for us when we were rolling out a change to a cluster to drain the traffic away from a cluster, make changes, and then slowly introduce traffic back into it. Obviously, this isn't only useful for when deploying changes, but also when you're, say, seeing problems with a critical service in that cluster, you can drain that way. So it's something we use very regularly to this day. The multi-cluster support, though, in 1.4 was basic, maybe experimental, build your own adventure to figure out what on earth that looked like. And gRPC support was an afterthought at best as well. But we managed to work through all these. We built some of that custom functionality, and then we did sort of have a slight problem where we managed to leak the implementation to our users. So rather than our lovingly crafted homepage, allowing people to search for flights or car hire or hotels, or even our lovingly crafted error page, we managed to present to everyone that visited Skyscanner with RBAC access denied. Which, to be fair, some people very quickly went, I see you're using Istio then. However, that got us a long way. However, we ended up stuck on Istio 1.4 for a very long time, and significantly longer than we were really comfortable with, certainly significantly longer than our security team were comfortable with, for a number of reasons. The big one, however, was the removal of Mixer. And for those of you not familiar with Istio, that was a centralized component as part of Istio that was responsible for collecting telemetry, and therefore reduced a lot of complexity, etc. However, they called it Mixer removal, telemetry v2. More realistically for all of the users of Istio, it was actually all your monitoring goes boom. So Carl Stoney, I think, is still at AutoTrader, but his take on it was, oh wait, everyone now needs to run federated Prometheus for themselves, so all users of Istio are basically having to recreate Mixer for themselves and manage it themselves, which was not a fun time. So we spent a lot of time going, we'd rather not solve that ourselves too much. Which John will cover some of the ways we address that in a bit, though. We also decided to go from Kubernetes 1.21 to 1.23 at the time that we upgraded all the way from Istio 1.4 to 1.16, which was when we were finally comfortable. So it made diagnosing some problems when we performed the upgrade slightly more problematic, where we were going, oh wait, we've got the release notes for 12 versions of Istio, plus 2 versions of Kubernetes to try and untangle what we've changed the networking to suddenly see a pile of 499s where we have a custom setup with NLBs, default gateways, etc. We eventually managed to find that this was just the new normal and it wasn't impacting travelers somehow, despite looking horrible in our graphs. We also had created a custom Helm chart. I think between Istio 1.4 and 1.16, it had gone from Helm chart to a completely different way of deploying it, back to a Helm chart. So we had to try and figure out what had changed between their 2 entirely separate ways of creating Helm charts for deployment. There was also 12 versions of config. So a pile of config that we had lovingly crafted over the years did not work, had been deprecated, had moved 2 major versions, etc. Things had been renamed, so there was a lot of trying to figure out what was going on there. And finally, Envoy version. So one of the joys of Istio, obviously, is it's built on top of other cloud-native technologies, and mostly Envoy. However, we built custom Envoy filters to do a pile of stuff, which now we were also committed to upgrading the Envoy version. Turns out those all broke as well. So had to drag in other teams within Skyscanner who were responsible for maintaining that. It's not all bad news, though. It has brought us a lot of joy.
Yes, I get to talk about the nice bits. So guys talks you through the pain of this upgrade process, but we do have some cool things in Istio these days. So as Guy mentioned, we had Mixer and then Telemetry V2, and what does that look like in today with Istio? For those that weren't in the Open Telemetry chat next door previously, we had Dan, where is he? There he is, with us at Skyscanner, and we implemented a custom way of generating Istio metrics from spans, which give us nice dashboards. So we have a single dashboard for services that they can go in and you can see all the services that are calling them, what's happening within their service itself, and all the dependencies that that service itself calls, which we were very happy with. We also, to the pain of some people in this room, we've built a system that allows us to outlier detect localities. As Guy touched on, we implemented draining. So draining requires locality weighting. Locality weighting is not compatible with outlier detecting localities. So by building this system that we have, we are able to do that naturally. So we can support weighting whilst a service can call another service in a separate cluster, and it can have, let's say, 3 failures. And after that, it just immediately stops trying that locality. It stops trying that cluster, and we'll try another one, which isn't really possible with native Istio just now. How does it work? We have a complex system. We have, as Guy said, we've got a Istio gateway per cluster that all our traffic routes through. We then attach a network load balancer to each gateway, and we give that network load balancer an IP. And then for a service, so if service A wants to call service B, they just call serviceb.skyscanner.io. And an Istio service entry basically points at these NOB IPs, gives it a locality, and the traffic ends up going to that gateway in the other cluster. And if it just receives 503s, it will just stop trying that IP and we'll try another IP. However, load balancers cost a fortune. We also have a special gift for this. We at Skyscanner process, I don't know, 60 million requests a minute or something? Something like that, across our microservices. Now, when we look back at the architecture that we have here, we see that every single one of these requests goes through an NLB. NLBs don't cost that much when you don't use that much for them, but at our scale, we realized it was costing us a lot of money. So we made it's our mission last year to move to Istio multi-cluster. And what this looks like, as you can see on the graph on the right, is instead of calling an NLB for same cluster traffic, we just go straight to that default gateway via the cluster IP. That still gives us a single IP route for a single locality. And then for multi-cluster, we do it in obviously a non-standard way at Skyscanner. We call an egress gateway via a single IP, and that egress gateway then transits that data to a remote default gateway, and the pattern stays exactly the same as it was with an NLB. And we use standard Istio sidecar multi-cluster discovery for this. So what does it give us? Implementing multi-cluster saved 10% of our entire company-wide AWS costs, which is quite a lot of money. It also helped our scaling. So when we had NLBs, my formatting is slightly off here. When we had NLBs, it would take us 2 minutes for a new default gateway pod. We use Spot, we use Carpenter, everything moves around a lot, it scales up and scales down. It would take us about 2 minutes for a new gateway pod to register to this NLB, and that's quite a lot of time. So now with multi-cluster, it's about 20 seconds. With that shorter period of time, we can increase the average CPU utilization that we run for gateways like this, and that means it costs us less. We spend less money on pods. What it does mean is Istio is doing a lot more work. It's, instead of just scraping its own cluster, it's scraping every other cluster in the region. When we generally run 6 clusters per region. So I think we scaled up about 5 times. We went from 5 pods to 25 pods for Istio. So that's a side effect. Worth it. But, service impact, none, essentially. We actually have very slightly lower latencies. We managed to do this migration without any impact or any asks on service owners, because we, as a platform team, control all the routing, and they just register their service, basically. What else have we done with Istio? We have done some nice bot detection at gateway levels. That saves us some money. We can do it internally. We have a public gateway as an Istio gateway behind some ALBs, and we actually deploy as authorization policies and so on, bot detection at that level, instead of running at a Lambda edge. Again, another big cost saving. We have native cross-region failover, so for services that are compatible, not every service is. If a request comes in to your EU West 1 region and it goes to your service and it fails, it will automatically fail over to a cross-region gateway in EU Central 1 or even AP Northeast 1, so on. We do this from Istio client to Istio server in another region, so this basically gives us a global mesh with MTLS end-to-end all across the world. We have moved some, this is a smaller one, we've moved some headers from our CDM, and we now pull them out with a nice WASM envoy filter. We were spending, again, a lot of money pulling these headers out of our CDN, and now we can do it fully in-house in Istio with resources, with gateways that we already have and we're already paying for. And GitOps. GitOps is something we've been rolling out over the last couple of years, and Istio is fully supported with an Argo rollouts. So it means that Argo rollouts essentially selects pods, canary pods, stable pods, and it will do that whole transition for you for a new deployment. It does it all behind the scenes for you with a virtual service and destination rules. Very nice. And lots more. We've done a lot more, but this list is definitely not comprehensive. Looking forwards, we've implemented a lot of things that we wanted to do, but we have a lot more that we do want to do with Istio. One of these things, is anybody using Ambient? Yeah, Solo are using Ambient, of course. One of the things we want to do is move to Ambient. For those that aren't fully aware of the Istio architecture, every pod that you run, it gets a sidecar. Sidecars are heavy. Service owners have to actually think about them, because sometimes if they run it in a special way, these sidecars will run out of memory or CPU or so on. So they do have to think about it, and we want to abstract that away from them. So what is Ambient? Instead of sidecars, we use ztunnels instead, a daemon set. So every node runs one ztunnel pod, and with the Istio CNI, it basically injects itself into your service pods, and the route tables do some magic, and it goes through a ztunnel instead. No more sidecars. However, ztunnels are only compatible with layer 4. So with sidecars, you get layer 7 out of the box. You can do whatever you want. Authorization policies, header-based routing, so on. Things you can only do with layer 7. You cannot do this with ztunnel. So, waypoint. That's another Istio concept now, that if you add a waypoint to your service, it will go from the ztunnel to the waypoint, and you get the same features, asterisks, generally the same features, as you do with a sidecar. And then it will still just go to a ztunnel for your destination. We want to do it. It will save us money. It will greatly simplify our architecture. Our mesh is complicated, as you can probably understand from what Guy and I have both talked about. There is a lot of what we call Skyscannerisms that aren't fully compatible with Ambient out the box. So we are in the middle of that process of planning out how we're going to do that. What else do we do? We, like most companies, most large companies anyway, run lots of AWS accounts. That run different services on these AWS accounts. For example, we've got data, security accounts, so on. And they want to access things that we run in our main platform. How do we do that? Right now, this is how we do it. We, for each account, it will get a VPC endpoint. Again, this is all AWS terminology. Sorry, not AWS. VPC endpoint to our main VPCs, the ones that we control, where all of our microservices run. And then each account will then get its own Istio gateway where we can apply all these different routing rules, so on. This is what we do just now. It's fine, but it's a lot to handle. We have a lot of gateways, we have a lot of NLBs, we've got to manage all these VPC endpoints, a lot of things to consider. So we want to try and leverage Istio in some way to make a single gateway that instead of being attached at a VPC endpoint for every account, we inject authorization information, and then we use an Istio gateway to pull that out and see, are you allowed to go where you're trying to go through this gateway? Far simpler. One of the things we've worked on very recently is rate limiting and what we call quality of service, priority and fairness. This is very recent, last couple of weeks. We have allowed services to basically identify the type of request. So as at Skyscanner, we obviously have things like app, we've got the website, we've got mobile website, we've got batch jobs, partners, and so on. We are letting services now identify the type of request that they've received at the very top of the stack, the top of the funnel, and they can then set that as a value. And we're going to use, well, we do use OpenTelemetry baggage, shout out to Dan. And then the services will automatically pull this when it's available in context and send it as an outbound header. And we, as a platform team, then leverage Istio to say, if you as a service owner, if you receive a request from the app, which is important, then do this with Istio. You can give it more retries, you can just give it more headroom. If it's something less important like a batch job or something else, you can basically tell it to go away. And this is our resilience method for when we have disaster scenarios, scaling problems. Can't do a presentation without mentioning AI. This is just a very short one, something we as a business are obviously looking into, like a lot of other businesses, is a kind of AI gateway implementation. Right now, when you see services develop their AI stuff, they're using Bedrock, they're using SDKs out of the box for OpenAI, so on. And we want to, again, as a platform team, abstract away everything we can. So we also want to abstract away AI. And for those who aren't fully aware of the concept of what AI gateways are, you basically get an open standard endpoint, and the AI gateway can help you choose models from SaaSes, so ChatGPT, whatever, or it can also route to your own self-hosted GPU inference models, can do failover, rate limiting, and your service owners don't see any of this. They just say, I need an AI model, and the gateway will handle all of that for you. Again, very, very early days in this, but something we're looking into. And that's it. Any questions?